Well, how are you doing? This is going to be a very quick video addressed to Sean Hawkins in particular. Sean is asking for a long time how can we explain how Polaris drops by 1 degree every 69 miles across a horizontal plane. Now, I've already addressed this twice of how it happens, why it happens, and I made two videos recently. I made two videos before this one, and I made another one months or ages ago. But I've addressed it to Sean many times, and many people have. And Sean keeps on asking for the same thing. Now, the reason Sean keeps on asking is because he only has one interest in one thing, and that is his own explanation, which is based on his own globe nonsense. So I'm going to just completely ruin that right now, and hopefully this will end Sean asking people for evidence of something that he has no evidence for. This is Polaris. This is the globe, right? I even made it an oblate spheroid. I even made it extra wide to help out, so it'll be more flat at the top and bottom, right? So here is all the angles. This is zenith to Polaris. This is Polaris up here, obviously. These are different angles down along the globe, right? Here is the equator line. This is right at the equator. It is impossible on his globe to see Polaris from the equator, right? If they want to even try adding refraction in, right? What refraction is that, Sean, that you're adding in? How are you going to make Polaris be all the way over here? You're not. That's not going to happen. Number two, Polaris, they're going to claim, Sean Hawkins is going to claim, Polaris is this big, huge star at 400 plus light years away. Well, Sean, please provide us the one-way speed of light measurement, because that is what your light years are based on. So everything that you're claiming is based on an R value and a one-way speed of light measurement. A measured R value and a measured one-way speed of light measurement. Sorry, a measured one-way speed of light. Those things don't exist, Sean. Right? I'm going to show you now. Right? 1 second. So I put this onto the equator here, right? This orange line on the other side. And I'm going to do this, right? To Polaris. Look down here. See that blue down there? That would mean that it's going through the side of your sphere. So it is impossible to see Polaris from the equator on your globe model. Your globe model has no relevance. There's no measured R value. And your distance to Polaris and your claims of what it is are all based around the speed of light. But there is no one-way speed of light measurement. It doesn't exist. Neither does a two-way measurement. Only a two-way calculation. So Sean, this is, which one is it? This one. This is what Sean. This is what it is. This is all it is. This is a demonstration of how the sun sets and rises, right? But this is all it is. I'll bring down the sound now. Right, the same thing happens with Polaris as you move away. It's exactly the same thing. As you can see, that's a laser I have. As I move it away, as I move that away, the laser, in moving in a straight line across a horizontal, is just optical drop, appears to drop, because the reason is the angular free space. So just to show you what I mean, this bit of free space here between the surface of the table and the bottom of the light, that's the same amount of free space as was here. Exactly the same amount of space. It's just as it goes away, right? 1 second now, I'll leave it, get into view. As it goes away, that angular free space changes in angular size. That's all it is. There's nothing to it. It's very, very simple. And if there is any refraction going on, then it's not 7/6R, because R doesn't exist. So that is the end of that. If Sean Hawkins is asking anyone for any more Polaris nonsense, send him straight to this video. He has nothing. He doesn't have a claim of his own. He has a claim of an R value that doesn't exist and a claim of a one-way speed of light measurement that doesn't exist. He has nothing. Absolutely nothing. And you can't have an angle on a curved surface, Sean. Wake up.